Lesson 8.4, Special Products. Our essential question says, how do you square a binomial? Under questions, you notice that we have 3 new vocab words today, or properties to look at. In this course, we are really going to focus with foiling and not memorizing with special products. When you're in a more advanced math class, you probably will just be able to recognize special products and use some shortcuts. But for now, we don't want you to try to memorize that because this is our first time working with multiplying binomials or multiplying polynomials in general. So we just want you to work on the skills instead of trying to memorize some patterns. So the square of a sum. Squaring something means multiplying it by itself, and the square of a sum means that your term had a plus in it to start with. So right here, you see the plus sign. This plus sign indicates that it's a sum, and this exponent just indicates that you're squaring that sum. Similar to that on the next one, square of a difference. Difference is subtraction. Squaring it means multiplying it by itself. So you notice that what we have written over here on the right-hand side is x plus 3 times itself, and then x minus 5 times itself. So the exponent means that you repeat what you see in the parentheses, and in both of these cases, it's a binomial. So you repeat that binomial and multiply it by itself. Which brings us to what we did in the last section. We're going to be foiling it then. Because whether you connect them with the distributive property or the smiley face, you're still using FOIL. Then the last one is called a difference of squares. A difference of squares. Difference has a different meaning here. Difference here means one has a plus and one has a minus. So we're using the word difference in 2 different ways. Once we're using it because difference can be subtraction. The other we're using different as in opposite signs. Opposite signs. So the binomials look very similar to each other. The only difference is that one has a plus and one has a minus. And then again, of course, we're going to FOIL it to figure out our answer for multiplying those together. So find the product. X plus 8 squared. X plus 8 squared. So x plus 8 squared, the square means multiply it by itself. So that's exactly what we're going to do. So x plus 8 times x plus 8. If I FOIL this, first, x times x is x squared. Outside, x times 8 is 8x. Inside, 8 times x is 8x again. And then last, 8 times 8 is 64. I connected these like the distributive property. So I distributed my x first times everything in the second binomial. Then I distributed my 8 times everything in the second binomial. So these 2 terms in the middle, the outsides and insides, if I combine them, I get 16x. So then my final answer is x squared plus 16x plus 64. Next one, 2x minus 1 squared. So that means 2x minus 1 times another 2x minus 1. FOIL it. First terms, 2x times 2x would be 4x squared. Outside, 2x times negative 1 is negative 2x. Inside, negative 1 times 2x again is negative 2x. And then last, negative 1 times negative 1 is positive 1. So you may notice that the middle terms are the same again. That's the pattern that we're talking about. So negative 2x and negative 2x combine to give you negative 4x. So 4x squared minus 4x plus 1 is my final answer. So you can expect to see that the outsides and insides give you the same result on these, whether it's a sum or difference. Now find the product. X minus 2 times x plus 2. So this was called a difference of squares. So what you're going to see on the answer for these is something a little different. You're going to see a difference of squares in the answer. So first terms, x times x is x squared. Outside, I'm going with the smiley face now, x times 2 is 2x. Inside, negative 2 times x is negative 2x. And last, negative 2 times positive 2 is negative 4. So, check out our like terms on this problem. 2x combined with negative 2x is 0. They cancel each other out. So our final answer is x squared minus 4. Now remember how we said this method, that this pattern was called a difference of squares? Both of those terms are perfect squares. So both are perfect squares, and they're being subtracted, which is why it's called difference. So perfect squares, x squared and 4 are both perfect squares, and they're being subtracted. So difference does mean subtraction. So difference of squares was not referring to the two binomials that we're starting with, but instead referring to the answer. Our next one, find the product. 5x minus 1 times 5x plus 1. Smiley face again. 5x times 5x is 25x squared, which is a perfect square. Outside, 5x times 1 is 5x. Inside, negative 1 times 5x is negative 5x. And last, negative 1 times 1 is negative 1. Combining the two terms in the middle, outsides and insides, they cancel out, so we are left with 25x squared minus 1. And again, it's a difference because they're subtracted and they're both perfect squares. Okay, moving on to something tougher here. Both of these figures are squares. Find the red shaded area. So the shaded area, to find the shaded area, I'm going to take the entire square, so the big square, and I'm going to subtract away the little piece that's not shaded. That would leave me with the part that's red. So this whole thing, I'm going to take the whole thing, and then I'm going to subtract that little square that's not shaded red. And that would leave me with what you see in the picture. Okay, so I need to FOIL to find the area of the square. You've got to multiply length times width. And then over here, I'm going to do the same thing. I'm going to FOIL, and then I'm going to subtract them. So, my first one, x squared plus 9x plus 9x plus 81. And my second one, x squared plus 1x plus 1x plus 1. Okay, so I've got x squared plus 18x plus 81 minus x squared plus 2x plus 1. Now, please remember that when you're subtracting your polynomials, I actually don't like to subtract them. I would rather add the opposite. Or think about it as distributing a -1. So if I turn this into a plus, all of these turn into opposites. Now, I need to do my like terms. Combining x squared and -x squared, they cancel each other out. So they're gone. Combining 18x and -2x. 18 plus -2 is 16x. And then I've got 81 and -1, so that would give me 80. So my final answer is 16x plus 80 units squared. So I found the area of each square, and then I subtracted them to get the area in between. You should be able to write a summary now, and then check with your teacher for your homework assignment.